Okay, hello everyone. Today we're gonna review a journal, international journal, the structure of international journal called Assessment on Safety and Performance of Super High Arch Dam with Asymmetric Foundation and its Reinforcement Effect Identification. So this is a summary of the journal. The journal issued by Structures, publisher Elsevier Limited, and the author of Yu Li, Erfeng Zhao, and Ling Ziu Hu, Chenfei Shao, Zihao Dong, and Qiaojun Zhong. So this is the quartile Q1 journal. Each index is 70, and the coverage is 2015 to 2025. So, the introduction of the arch stem are thin but strong structures that rely heavily on the support of the foundation. However, many large stems are built in areas with complex geology and asymmetrical topography, causing uneven deformation and reducing stability. So this paper discusses the influence of asymmetrical foundations on the safety and performance of super high arch dam and evaluates the effectiveness of reinforcement measures. So this is the topic of the super high arch dam, and the main focus is Jinping Wan Dam in China, which faces highly asymmetrical geology and topography. And the characteristic of asymmetric foundation. So characteristics of asymmetric foundation in arch dam are critical to understanding their performance and safety. The key features are one, uneven deformation. Asymmetric foundations lead to uneven deformation patterns in arch dam. For instance, the Malpasset arch dam experienced rotation around its right base, causing significant cracking and ultimately leading to its collapse in 1959. This highlights how foundation asymmetry can result in severe structural issues. So you can see the figure that the collapse of the Malpasset arch dam in 1959. The red line is ground line after accident, and the blue lines is dam foundation lines. And then the pictures show the residual dam after accident. B. Geological and topographic influences. The asymmetry can arise from both geological and topographic factors. For example, the Zephyrelia arch dam exhibited transverse cracks due to the gentle slope on the left bank and a steep slope on the right bank, which caused an even stress distribution and deformation. In figure below, you can see that elevation view of arch crown beam section of the Zerfelia arch dam. The ground surface line you can see, and then excavation zone, and so on, also dam foundation line. And then sensitivity to asymmetry. The degree of asymmetry in the foundation significantly affects the dam stability. The Jinping 1 arch dam, noted for its high degree of asymmetry, showed that the largest deformations under overload conditions, indicating that the structural integrity is highly sensitive to the foundation characteristics. In the first figure, you see that the Jinping 1 arch dam, the pattern of the deformation is ununiform, and then the Xiaowan arch dam is more likely in the Jinping 1 arch dam, but slightly ununiform. And the third one is the symmetrical arch dam. You can see that the deformation is uniformly. And the local damage and overall stability. Asymmetric foundations can lead to localized damage in the dam structure, particularly at the abutments. This localized damage can compromise the overall stability of the dam, especially when coupled with environmental and geological factors. You see that the first picture, deformation of Jinping 1 arch dam, the factors of the deformation is likely ununiform. And then the Xiaowan Arch Dam, the deformation factor is more uniform, but it's still ununiform. And then the third one is deformation of symmetrical dam. So this is a factor of the deformation as the factor is uniformly. So this is the more stable for the foundation of its structure. So this is the structure that the asymmetric has asymmetric foundation needs reinforcements. The presence of an asymmetric foundation necessitates specific reinforcement measures to mitigate risk. These measures include setting cushions and strengthening the foundation to adapt to complex topography and geological conditions. You can see that the picture shows that the diagram of reinforcement that happened or the conducted in Jinping-1 Arch Dam. And reinforcement strategy applied in Jinping-1 Arch Dam are installation of concrete pads at left abutment, location between elevation 1,730 meters below the sea, meters uh, above sea level to 1,885 meters above sea level. The objective was to overcome the sloping topography and increase local stiffness, and the simulation done used by CDP, concrete damage plasticity model. The second one is excavation and big fill with concrete. So at fault zones and weak rocks such as Dike Lamprophire X and F5 fault. The process starts with local excavation and then filling with high strength concrete. The third one is consolidation grouting. So this is applied to low resistant rocks in retaining block foundation. The objective is to strengthen the rock mass and reduce permeability. The fourth one is equivalent model for grouting and concrete. So the principle of energy equivalent is used to obtain the stiffness parameter. And after that, numerical analysis was also conducted before and after reinforcement to measure the impact of reinforcement measures. On first is plastic zone. So before reinforcement, last plastic zone on the left abutment indicating weakness. And after reinforcement, plastic zone was significantly reduced. Many areas returned to elastic status, indicating that increased strength of the foundation structure. And maximum deformation also measured before reinforcement was 250 millimeters under load of 5 times normal water pressure. And after reinforcement is 231 millimeters, and the deformation pattern becomes more symmetrical. Factor of safety also conducted by K1, K2, and K3. K1 is crack initiation. Before reinforcement, the number is 1.4, and after reinforcement is 1.58. The K2 is nonlinear deformation. Before reinforcement, the number is 2.50, and after reinforcement is 3. And the third one, the K3 is total strength limit. The number is before reinforcement is 5.1, and after reinforcement is 5.80. So this is the significant increase in all three indicators indicates that the structure becomes more resistant to higher loads. And the last one is deformation energy. Before and after is similar at low medium loads, and at high loads more than 4.5 times the deformation energy of the unreinforced dam rises dramatically and instable, while reinforced one shows a more controllable energy growth. Okay, and also catastrophic theory analysis was also conducted. So status of delta interpretation, Before reinforcement, it was minus of 29.093 system, so it is instability. And after reinforcement is plus 46.976 system returns to stability. The change in sign of delta indicates that the reinforcement successfully transformed the system from critical to stable states. And also integration of MLPR-based safety model. After retrofitting, the multi-layer perceptron regression model was used to evaluate the relationship between loads, it means water level and temperature, and safety factors in real time. Results show that under high water level and low temperature, K1, the number is 1.45, before retrofitting is 1.25. Under favorable condition, low water and high temperature. And K1, the number is 2.5, before retrofitting was 2.3. This is confirmed that rainfalls increase the safety figure, especially under extreme condition. So the last one, the general implication. In general, the retrofitting measures undertaken had positive impacts, such as water load transfer became more evenly distributed to both sides of the abutment. Long-term stability increased, deformation asymmetry was corrected, and the overall structure became more homogeneous. So you can see that the figure in below, load control diagram before reinforcement in the left, and so load control diagram after reinforcement in the right. You see that the number is increased, the crack initiation safety factor is increased after reinforcement, the water level also, and also the temperature. So for the reinforcement and all of the conducted action is more give the more stability for the foundation of asymmetric arch dam in Jinpingwang. So the key conclusions are, first one, influence of asymmetric foundation. The study highlights that asymmetric foundation significantly affect the overall stability of arch dam. The deformation and damage of arch dam under both normal and overload conditions are sensitive to the degree of asymmetric in the foundation. And the second one is reinforcement measures. The research identifies effective reinforcement strategies, such as setting cushions and strengthening the foundation, which can mitigate the adverse effects of foundation asymmetry. These measures have been shown to improve the stability and performance of the dams. So before and after reinforcement, they conducted the simulation, the simulation of the model for the reinforcement and also before the reinforcement. And the third factor is safety factor evaluation. The paper introduced three safety factors to assess the overall safety of arch dam. After implementation reinforcement measures, the safety factors of the dams were found to be greater than before, so indicating the enhancement of the stability and also the safety of the dam after the reinforcement has done. And the fourth is performance under load condition. The study reveals that the Jinping-1 arch dam, which has the highest degree of asymmetry, exhibits the most significant asymmetry for deformation and is prone to local failure under overload condition. In contrast, symmetrical dams show more uniform deformation. I already explained it in the slide before. And the fifth conclusion is the long-term safety and monitoring. The research establishes a relationship model that quantifies the safety factors of arch dam in real time based on monitored conditions such as water level and temperature. This model aids in predicting the long-term service performance of the dam. So I said before, the K1, K2, and K3 and MLPR method. And the overall benefits of reinforcement, the finding indicate that the proposed reinforcement measures not only correct the influence of symmetric foundations, but also enhance the overload capacity and long-term safety of the arch dam. So this conclusion underscores the importance of understanding the effects of a foundation asymmetry, implementing appropriate reinforcement strategies to ensure the safety and performance of the dam. So this is all that I have to explain of the asymmetric and the reinforcement of the foundation of Jinping Wang Dam. Thank you very much. Have a good day.